So this is what the set of notes look like. We talked about quadratic equations. Remember, we have 4 ways to solve quadratic equations, right? We can factor, we can square root, which is probably the easiest one. We can complete the square, which is probably our hardest one. And then using the quadratic formula, well, I think it's kind of tied with square rooting. I think the quadratic formula is pretty easy as well. So we went through everything except the quadratic formula yesterday. So I kind of told you that the quadratic formula was something that we had to memorize, right? If you want help memorizing it, there is a song that is on YouTube that I refuse to sing. So go ahead and take a look at that if you haven't memorized it already. And then I did an example of solving something using the quadratic formula. I think I got you guys to try this one, or maybe we just did this together. I'm not sure. Oh, we did. Okay. Oh, we actually didn't finish that one. So, man, why did I do that? Why did I stop in the middle of the problem? That's okay. You know what? It's all good. Let's go through example 7 real quick. The first thing we did was distribute. So we got an expanded version of this multiplication on the left-hand side. After that, with the quadratic formula, you need one of the sides to be 0. So I just subtracted 3 on both sides. So I got 0 on one side. So everything's on the left-hand side, 0's on the right-hand side. After I did that, I think it's easier to write the equation in order, like have the x squared go first, the x go second, and the number go third. And the only reason I rearrange it like that is because sometimes I mess up and I don't realize what A, B, and C should be if I don't write it this way. So you don't have to write it this way. I just think it's kind of helpful if you do it. After that, I realized that A was -2, B was 6, and C was -3. And I basically just plugged it into the quadratic formula here. So this is just me plugging in A, B, and C into whatever the quadratic formula says. Okay. After that, I think where we left off was I found that 6 squared was 36. So I guess my next order of business would be to multiply 4, -2, and -3. What is 4 times 2 times -3? Yes, 4 times -2 times -3. Positive 24. Perfect. All right. And 2 times -2 is -4. Okay.
That's for 12.
Yeah, I guess it would be -6 plus or minus. This is 12 when you do the subtraction. Yeah, I can't really make that a whole number. So honestly, if you leave your answer like this, I will completely give you full credit for that. That is totally okay. I will show you how to simplify it even more if you want to see it. But this would be fine as an answer. Okay. I just have to do this because I'm a math person and it's annoying me. 12 is 3 times 4, right? So I can rewrite 12 like that, right? If I have a square root of multiplication, you can split up the multiplication as the square root of 4 times the square root of 3, right? And since I have the square root of 4, I can rewrite that as 2, okay? And actually, on top, I can take out a 2 from both of the -6 and the 2. So I can take out, well, I can take out a -2 if I wanted. So this would become 3 plus or minus the square root of 3 over -4. And then the top and bottom would cancel out. So this would become 3 plus or minus the square root of 3 over 2. Okay, so that just was annoying me. You could leave it. If you left your answer like this, I would give you full credit. But if you want to go ahead and simplify your answer to get here, be my guest and I will, I'll be pretty impressed. All right. Any questions on this quadratic equation? Any questions? All right. Oh, yeah.
How'd you get from 36 to 24 to 12 and -6?
So 36 minus 24 to what?
6 and square root of 12.
Yeah, so from here to here, all I did was subtract 36 minus 24. So that's why there's 12 there. Yeah. Any other questions? All righty. If we flip to the next page, we have an example of our harder question combined with quadratics now. Okay, so I believe that something like this was probably the hardest question on the exam. No, that was last week, right? This is an example of a rational equation because there's x in the denominator, right? Now, rational equations don't have to just turn into linear expressions, they can turn into quadratics as well. So why don't we just do an example of this and see what happens? Okay. before we do a rational equation, my biggest hint to you is to look at the denominator and see if there's anything that can be factored. Is there anything that can be factored in the denominator here? Look a little closer. Yeah, that x squared minus 9, right? Now this has two parts in the expression. So what formula am I going to use to factor that? Or what it's called? Remember the difference of squares formula? The a squared minus b squared. Using that formula, what does this factor to? Perfect. All right, just using that formula, you figure out what a and b are and plug them into the formula. Okay. So instead of writing x squared plus 9, I could easily write x minus 3, x plus 3, and it'd be the same. Okay. Taking a look at the denominators, what do you think should go in the LCD? Perfect. X minus 3, x plus 3. Okay. Now I wrote them again on the right-hand side. Do I have to write x minus 3 again? No, right? I already wrote it down, accounted for it once. I'm good. Next, we want to find out what our answer cannot be. So I guess that means I need to take each of the components of my LCD and set them equal to 0. So just like we did before, yeah, x equals 3, x plus 3 equal to 0 gives us x equals negative 3. So if I do my equation and I get either 3 or negative 3, that's not my answer, right? Okay. So what do you think my next step should be? I'll give you a hint. It's written down on the paper. Perfect. Multiply the LCD on both sides. So I'm going to rewrite my equation here. 2x over x minus 3 plus 5 over x plus 3 equals 36. Instead of writing the denominator like x squared minus 9, I'm going to factor it out like I did above. So I'm not writing it like how the question is asking it, just because it's going to make it easier when I cross things out. Well, just like Evan said, I'm going to multiply both sides by the LCD. So the left-hand side is going to be multiplied by x minus 3, x plus 3. The right-hand side is also going to be multiplied by the same thing. Okay. And any ideas on the next step? Yep, distribute, just like we did on the test, right? It's literally the same steps. We didn't do anything different so far. I'm going to take that LCD and I'm going to distribute it to the top of the first two terms in there. So this becomes 2x, x minus 3, x plus 3, all over x minus 3. Okay, and I got that by just multiplying my whole LCD by the first term. So it's literally the first term with the LCD on top. Okay, I'm going to do the same thing to the second term. This becomes plus 5, x minus 3, x plus 3 over x plus 3. So now I'm done with the left-hand side. I just multiplied the LCD by the top of both of these to get this guy here. Okay. On the right-hand side, basically the same thing. I have 36, x minus 3, x plus 3 over x minus 3, x plus 3. So I basically just attach the LCD to the top of every single thing in the equation. All right. What's my next step? Cancel, right? I have x minus 3 on the bottom, x minus 3 on top. I have an x plus 3 on the bottom, x plus 3 on top. And I actually cancel out two things in the right-hand side. All right. Let's see what we have left. On the left-hand side, I'm left with 2x times x plus 3. The next term, I'm left with 5 times x minus 3. And then on the right-hand side, I guess I'm just left with 36. All right, everything seemed to cancel out there. All right, next step. Distribute, perfect, right? I have a 2x. I can distribute that over to the x and the 3. I can take that 5 and distribute it over to the x and the minus 3. What's 2x times x? 2x squared, perfect. 2x times 3 is plus 6x, okay? Moving on to the next term, I have plus 5x minus 15, just multiplying the 5 over. And then on the right-hand side, I'm still having the 36. I have to keep writing that down there. All right, we're getting close. What else should I do? How can I simplify this even more? Combine like terms, perfect. So this becomes 2x squared plus 11x perfect minus 15 equals 36. And at this point, I know I have a quadratic because my highest power is 2. There's multiple ways I can I can go ahead and like solve this. What do you think like the easiest method is?
Get an X alone, so I would add 15 so it's 4.
You could get x alone, but that's only for the completing the square, right? Do you want to complete the square? I personally don't want to complete the square.
I'm sorry.
No, you don't be sorry. I just don't feel like doing completing the square. Any other ideas? Get it equals 0. We could factor or we could use a quadratic formula. Both of them make some, we have to have 0 on the right-hand side, right? So let's subtract 36 on both sides. 2x squared plus 11x, is it minus 51, I think, equals 0. Perfect. Now, do you really want to factor that? I don't feel like factoring. That is a 51 in there. That's a little scary. I don't even think it can be factored, honestly, into whole numbers at least. What type of method we should use? Yeah, I think the quadratic formula is pretty easy because you just stick the numbers into the formula. So why don't we go ahead and use the quadratic formula for this? Okay, I think quadratic formula is pretty easy. Okay. Now, what's A in my formula? 2b, 11c, negative 51. As I was, I don't know, I think I was walking around earlier today in my other class. You should never have x for a, b, or c. So like I see a lot of people saying a is like 2x squared. If you put x in the quadratic formula, it gets really nasty. So you should only have numbers for a, b, and c, no x values. Okay. X equals negative b, negative 11, plus or minus the square root of b squared, 11 squared, minus 4ac, all over 2a. So all I did is I just plugged in the numbers into my formula. Okay. So I can't really do anything with the negative 11. What's 11 squared? 121, good. I'm going to keep the minus sign. What's 4 times 2 times 51? Oh, negative 51, yeah. Or let me do that in my calculator. Perfect, negative 408, good. And then 2 times 2, that's easy, that's 4. Okay. Looks like the negatives can cancel each other out, right? I have a negative and a negative, so this is just plus. Okay. Let's go ahead and rewrite this as negative 11 plus or minus 121 plus 408 is, yeah, I think you're right, 549. Oh my goodness. You're right. Oh my goodness. I don't even trust myself when I do this anymore. I cannot add or subtract. I'm glad they didn't. I am glad that they did not make me add or subtract for my master's degree. That would have been sad. Okay. What's the square root of 529? 23? Perfect. That's really nice. I actually didn't even realize that when I was doing this question in my notes. Okay, so this is as simplified as we can get right now. Why don't we find the actual numbers that this turns into using the plus and the minus? So we actually have 2 answers here. We have a plus version and a minus version. Let's do the plus version first. Negative 11 plus 23 over 4. And that turns into, let's see. Did we get 3? Perfect. And then we can do the minus version, minus 23 over 4. 11 minus 23 divided by 4. I got negative 34 over 4, which turns into, oh gosh, negative 17 over 2. Yeah, negative 8.5 also works. Yeah. I would say stick with fractions in this class. Now, for this specific question, the decimal, honestly, I don't really care. Just for like WebAssign's sake or Alex's sake, I would keep it as a fraction.
We have a problem.
All right. What's the problem? Why is 3 not the answer? Yeah. Yeah, we said in part 2 that 3 cannot be my answer, right? So even though I got 3 as one of my answers here, 3 is not a solution, right? Because I said that it couldn't be an answer. So how many answers do I have for this question? Just one, right? My only answer for this question is -17/2 or -8.5. This is my only answer. Yeah, so here the discriminant, it really only works with non-rational stuff. Yeah, I would say like when you plug it in, you do get 2 unequal roots. Like it's true, but then with the rational stacked on top of it, it actually doesn't work. Yeah. And the thing about graphing is it's a little bit different than what we did before, because instead of dealing with like questions that just give you one variable, for example, every single question that we've done in this class before, you've been given a question that just has an X or just has a T or just has a Q. Later on in this class, we're going to be dealing with stuff called bivariate data, where we have 2 variables in every question. For example, an X and a Y, right? Whenever we have that, we can graph stuff on a coordinate plane like this one here. And to talk about the points that we plot on here, we usually use the term ordered pairs. Ordered pair. I think you've probably heard this term before. And an ordered pair is literally just something that tells us where we are in the graph. Usually we use parentheses with some sort of number to represent either the X value or the Y value separated by a comma. The first number in the ordered pair always tells us the X value. Okay. The second number in the ordered pair always tells us the Y value. Okay. So why don't we just do some practice talking about I don't know, ordered pairs here. I'm going to plot this point here kind of near the corner of the graph, okay? And if I were to talk about this point on the graph, well, the X value that it's at is -3, right? The Y value that it's at is 5. So I could say this point is -3, 5, right? I'll do one more. We have a point here when X is 5 and Y is 1. This would be 5, 1. 5, 1. Okay. So we can plot points on a graph. You've probably seen graphs that have points. You've probably also seen graphs that have a bunch of lines on them. And lines come about when we connect 2 points together, right? So, oh, that looks really bad. Let's try that again. That's, I don't know what I'm. let's just try this one more time. There we go. It looks a little bit better. It's still not that good, but at least I did something there. Okay. At least it's straight. All right. So lines come about when we connect 2 points together. And we can also talk about, like, sometimes we're interested in how long the line is, right? So what's the distance between 2 points and how long is this line? Now, of course, we can go ahead and take a ruler and like measure how long the line is. That's definitely a way we can go about doing it. But mathematically, there's actually a way that we can go ahead and, well, find how long the line is, okay? Now, there is a formula that is used to measure the distance of a line. It actually comes apart using, or it was created using this thing called the Pythagorean theorem. You've probably heard of it, where we take a right triangle to connect the line and come up with it. You've probably heard of that before. We're not going to go over the Pythagorean theorem in this class because it's not on the syllabus. So what we're going to do instead is we have a formula that tells us the distance between 2 points. Okay, this is a formula that you have to memorize. If you remember, yeah, I don't know. Honestly, for this class, if you do know the Pythagorean theorem, you might see how this comes about with the Pythagorean theorem by solving for C. But if you don't, I would just memorize this formula. Okay, so let me just talk about this formula. Let's say we have 2 points. P1 is just one of the points, and it has an X value, X1, a Y value, Y1. P2 is the second point. Let's say its X value is X2, its Y value is Y2. And let's just say I wanted to know the distance of the line that connects them, okay? This is how I would do it. First of all, we call it, like, the distance is D because it's distance. We put the 2 points in parentheses. It's just like notation. I won't really use that notation that much, okay? The distance is the square root of, subtract the X values and square them, subtract the y values and square them, and then you have the distance once you add them together and take the square root. Okay.
This does matter the order, right?
That's a good question.
Because I would hazard to say it does because it's not multiplication division. Or operations with theoretically.
Why don't we do it both ways and see what happens? All right.
The Kaggle book, but that would be a concept for me to help memorize it. I'm like this.
Yes.
Instead of having to know it second.
All right. So in this example, I actually have the 2 points that we just plotted, -3, 5 and 5, 1. Let's see if we can find the distance between these 2 points. Okay. Now, does anyone have a preference of to what P1 should be? You want the first point to be P1? Sounds about right. P1 should be A. If P1 is A, then I guess -3 is X1 and 5 is X, or sorry, 5 would be Y1, right? And then 5 would be X2 and 1 would be Y2, okay? All right. So actually what I'm gonna do is I'm gonna cut this in half because Zach does bring up a good point as to which one is P1, which one is P2. Let's just plug in to our distance formula and see what happens. Okay, so the distance between A and B is equal to the square root of X2 minus X1 squared. So let's do 5 minus, bless you, a -3 squared, okay, plus Y2, which is 1, minus Y1, which is 5 squared. Okay. Well, I guess to simplify this a little bit better, we could do 5 minus -3. I guess the minuses will cancel out. So this becomes 5 plus 3, right? So this becomes 8 squared plus -4 squared. All right. 8 squared is 64. 4 squared is 16. So when I add these together, I get the square root of 80. And that is the distance between the 2 points. Huh? Oh, you can simplify it. I would, if you leave it as the square root of 80, it should be fine.
Oh, really?
Yeah, Zach?
When I entered negative, did I have to add the parentheses -4 squared? I got -16.
Yes. Whenever you square something, you actually get, you always get a positive number when you square it.
Even though I didn't give me a negative.
Yes, because when you square something, it's multiplying it by itself. So if you multiply -4 times -4, it becomes positive.
-4 squared is -16.
The calculator does what you tell it to do. So the negative on the outside is telling it that you're not squaring -4, it's squaring 4. Yeah.
I don't know why it thinks that. Okay.
Yeah, it's just how computers think. It's kind of annoying.
That is why they'll never pass those.
Yes. One of my kids told me that if you square a negative number and get a negative number, Master Oogway will find you and punish you. So that's why I literally have a picture of Master Oogway here, so he can go and watch. Okay. All right. So let's. I don't know. That just cracked me up. I don't know why. Let's actually talk about what happens when we switch around the points. Okay. So Zach actually had a really good question here. Let's just say I made. I'm going to do a different color here. What if I made B X1 and Y1 and A X2 and Y2? Yeah, it actually doesn't matter. And I'll show you. So if you don't see it yet, let me show you what happens, okay? If we try to do the formula this way, it'll be -3 minus 5 squared plus 5 minus 1 squared, right? -3 minus 5 is -8 squared. 5 minus 1 is plus 4 squared, sorry, okay? And if you see what's the difference between these two, it's basically, the only thing that changed is instead of 8, I have -8, and instead of 4, I have, or instead of -4, I have +4, but we're squaring them anyway, so it doesn't really matter which one's negative and which one's positive, right? When I square them, I'll still get the square root of 64 plus 16, which is still the square root of 80. Okay, so it doesn't matter which one's P1 and which one's P2. The only thing that does matter is that if this one's X2, the Y value has to be Y2. It can't be Y1, okay? And if this one's X1, the Y value for that point has to be Y1. You can't have X1, Y2, okay? But the points don't really matter.
So if it were, this would be wrong. 5, let's say we that's the orange side.
So for example, if
It
5,
is 5 minus 3, and then no.
so if 5 is x1, you can't make 1 y2.
Right.
Yeah. So that would be wrong.
Right.
Yeah. Okay.
This what we need to remember is not necessarily the x down, whatever two is called, the x2 minus x1. You just need to remember it's x minus x.
Yeah.
Correspond to the. Because remember it's x minus x and y minus plus y minus y squared, which is squared, and make sure that
the points correspond to each other. Yeah. Yep. Are you Emily? You're not Emily? Okay, cool. I swear I've never had a problem memorizing names, but this semester I took on an extra class and I swear like that extra class just has messed up everyone's name and it makes me second guess everyone now. All right, so Emily wrote up her answer to example number 2. I guess it's kind of self-explanatory, so I guess I'm not gonna get her to explain her steps here. But I really like how she set up her equation. I like how she made sure that she took account the signs and canceled out negatives if there were 2 of them. And we should have gotten the square root of 17 as our answer. Any questions on example 2? Yeah. Yep, that's totally fine. Yep. Yeah, you can't even like simplify that even more. Yeah, so for this class, definitely don't do decimals. Decimals are not fun in this class, and like if you don't like, if it goes on forever and you cut it off, it's actually the wrong answer. Yeah.
So we don't have to like rationalize this class, like square root of 80, we don't have to be like separated like 240 times.
Not in this class. I will say like I know my 140 class, we do trig a lot and you do have to rationalize it, but I don't think I'll show up that much in this class. Yeah, you'll be good. All right. All right, so in addition to figuring out how long a line is, sometimes we're interested in, okay, if we have a line, what's the middle? Like where's the center of my line? Okay, we call that the midpoint, so like about the center of the line. And in addition to the formula for distance, we also have a formula for the midpoint. This is also a formula that I do want you to at least memorize, okay? But I have a little trick to memorizing this one, okay? Let's say we have 2 points, x1, y1, and x2, y2. Let's take a look at the midpoint formula. The x value says take x1 and x2 and divide it by 2. So essentially, we're taking the x values, we're adding them up, and then we're dividing by how many that there are. Does anyone remember the term that's used to describe when you add up everything and divide by how many?
Median.
Not the median. The mean, right? You're close. Well, we kind of are doing the median with the midpoint, but yeah, it's the mean, right? So we're basically taking the mean of the x values. We're actually also taking the mean of the y values, and we're just sticking them in the coordinates. Okay, so you don't really have to memorize the formula. Just know that you're taking the mean of the x values, taking the mean of the y values, and that becomes the midpoint. All right, let's do a little example. We're doing the midpoint of delta, -2, 3, and phi, 4, -2. It's phi. Yeah. Actually, some people do call it phi. I think sororities do call it phi, right? Is it phi? I know in Greek, I know in math it's called phi. Is there anyone in, is it phi mu? Phi mu? I know there's phi mu on campus here. Do they call it phi mu or phi mu? Phi? That's so weird. I know in math it's called phi, but if you're in a sorority, I guess it's phi. Oh, that's interesting. All right. So do you think it matters which one is x1, x2?
Like as long as like for example, if we make delta the 1.
Yeah.
X1, L1, Y1.
Perfect, right? Because we're just adding together the x1s and x2, so like it doesn't really matter which one we call x1 and which one we call x2, as long as we keep the 1s and 2s together. All right, so I just made the first one x1 because I thought that would be easy. So let's just plug it into our formula. Our formula really isn't like an equation, it's actually a point. So I have to put the parentheses, and we got -2 plus 4 over 2. And then the second coordinate is 3 plus -2/2. So let's try to simplify that. We have -2 + 4 is +2, right? -2 + 3 is +1. So I have 2/2, 1/2. And if I simplify this even more, 2/2 is 1. We got 1/2. That is my midpoint. All right. Any questions on example number 3? Pretty self-explanatory there, right? All right, this is where my last class left off, I think. So I think we're going to leave it here. And I think it's time for quiz review, right?